Okay, let's just dive right into this. Welcome to this Masterclass Explainer. Today, we are tackling one of the absolute most high-stakes environments you're ever going to face. And no, I am not talking about the Monaco Grand Prix. I am talking about your Cambridge computer science examinations. Just imagine a Formula One pit crew for a second. The car screams into the box, right? And in less than 2 seconds, literally 2 seconds, tires are swapped, aerodynamics are tweaked, and boom, the driver is released. Every single millisecond is calculated. Every movement has a precise systematic purpose. There is zero room for panic, zero room for wasted energy. Now, what if I told you that scoring top marks in Cambridge computer science, specifically for syllabus 9618, AS, and A-level, and building on those foundational concepts from 0417, 0478, 0983, 0984, and 2210 requires exactly that same level of systematic pit crew precision? It's true. Today, we're applying this high-performance racing strategy to a topic that shows up in literally every single examination series: security measures, specifically user accounts and passwords. We're going to decode exactly what the senior examiners are hunting for, and we're going to transform your exam strategy from a chaotic, nerve-wracking crash into a perfectly executed race. So buckle up, because every second of this explainer absolutely counts.
So, to get our engine started, we really need to ask the crucial question that senior examiners constantly debate. Why do students find multi-step calculations and method marks so incredibly hard? The source material we're analyzing today comes directly from principal examiner reports, and it points out a massive issue. Listen to this. Students are losing critical marks not because they don't know the computer science theory. They know the theory. They lose marks because their process completely falls apart under pressure. In the exam hall, the clock is ticking, the pressure is on, and just like a disorganized, panicked pit crew, things start dropping. Let me introduce you to our two struggling student archetypes. We see these two year after year. First, we have Alex. Alex is our overloader. And then we have Sam. Sam is our rusher. Both of them are about to face a standard 9618 question on implementing secure user accounts for a corporate network. They both desperately want that top grade, but they're both about to hit a massive wall. Let's see how this builds into a total textbook exam disaster.
This brilliantly illustrates the problem. Just look at this side-by-side comparison. On the left, we've got Alex's approach. The question explicitly asks to evaluate the security measures for user accounts. Now, Alex panics, zeroes in on the word security, and does a massive brain dump. Alex is writing about hashing, salting, biometric scanners, firewalls, encryption algorithms. It is literally a wall of raw facts. But there's absolutely zero analysis. Alex is basically a mechanic throwing 10 different tires at the car and just praying one of them sticks. Then, on the right side, we have Sam. Sam rushes. Sam completely misses the command word evaluate and instead just describes what a password is. Sam writes, a user account needs a strong password so hackers can't get in. And that's it. Sam thinks speed is everything, but Sam completely missed the actual requirements. Both of these approaches, they crash and burn during the exam. The result is just red pen marks everywhere. The examiner's report explicitly states that academic benchmarks require logical, structured reasoning, not superficial breadth. Just listing facts or giving generic descriptions is a guaranteed way to bleed method marks. So, how do we actually fix this?
Well, that brings us to the strategy reveal. It is time to secure those method marks.
Okay, the absolute core of the method mark strategy is this. Marks are awarded for the systematic process, the algorithmic thinking, and the evidence-based reasoning, not just the final answer. The theoretical architecture of this exam syllabus rests heavily on precise definitions, causal relationships, and integration. Top-tier students, they don't just write and cross their fingers. No, they approach these exams exactly like a systematic, error-free Formula One pit stop. The journey is honestly just as important as the destination. Examiners want to literally see your brain working on the paper. For a topic like security measures, if you just say use two-factor authentication, you might get a single mark. But if you explain the process, like how the system verifies the user's primary credential, generates a time-sensitive token, and then cross-references it to grant access, wow, now you're demonstrating algorithmic thinking. You're showing a step-by-step decomposition of the problem. And this is exactly where we introduce the PEAL framework: point, evidence, explanation, link. It is the absolute ultimate tool for structuring these evidence-based analytical answers that the Cambridge mark schemes heavily reward.
So the really crucial point here is applying a standardized sequence. Here's the 5-step procedural framework pulled directly from the syllabus guidelines. Think of this as our ultimate computer science success blueprint. Step 1. Deconstruct the question. You have to identify the command word. Is it describe, explain, analyze, evaluate? Step 2. Extract relevant data. Who's the user? What is the system context here? Step 3. Select your analytical framework. like that peel method we literally just talked about. Step 4, execute with clear notation and correct technical terminology. Don't just say, scramble the password. Actually say, apply a cryptographic hash function. See the difference? And step 5, present it correctly, linking it right back to the specific scenario. When you use this 5-step process, you are effectively calibrating your pit stop. You're making absolutely sure that every single action you take on that paper has a direct correlation to a mark on the examiner's rubric.
All right, it's time for an interactive challenge. I am going to show you 3 different answers regarding password security policies. I want you to pause this explainer for 30 seconds and see if you can spot the one that perfectly follows the Peel framework and our 5-step blueprint. Look for the point, the evidence, the explanation, and the link back to the context. Ready? Pause now. Okay, did you spot it? Option B totally nails it. Option B didn't just state use a lockout policy, it explained exactly why it prevents brute force attacks and linked it directly to the company's server security. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along into the transformation, let's see how we turn that red pen into green check marks.
Now really notice the transformation here. We've taken the generic, flawed answers from our students Alex and Sam, and we've upgraded them to a highly context-specific, methodical answer using our blueprint. We are transforming those chaotic, mark-losing responses into the exact high-performance answers that Cambridge examiners absolutely love to see. The new answer reads, to secure the corporate database, the system must enforce password complexity rules, requiring a mix of alphanumeric characters and symbols. This increases the entropy of the password, exponentially increasing the time complexity for brute force or dictionary attacks, thereby ensuring unauthorized actors cannot easily compromise user accounts. Do you see the difference there? It's huge. We integrated precise technical terminology like entropy, time complexity, and dictionary attacks. We established a clear causal relationship. Doing X prevents Y. The principal examiner reports explicitly highlight that candidates who reference these cross-topic connections, like bringing in time complexity when you're discussing passwords, achieve significantly higher marks. This right here is exactly how you secure the method mark. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's dive into our interactive workshop. Welcome to the Pit Stop Simulator.
Challenge 1. Data scan. I want you to pause the explainer and take up to 60 seconds to look at this complex data table. It outlines various security parameters for user accounts. Specifically, it's comparing different hashing algorithms against their time complexity, space complexity, and edge cases. What is the fundamental trade-off being shown here? Pause now.
Okay, we're back. If you notice that algorithm A is incredibly fast but requires massive storage space for rainbow table defense, while algorithm B is slower, meaning it increases time complexity, but requires less raw space, then you are spot on. The core trend you need to identify is the trade-off between computational speed and system security. Top-scoring candidates constantly demonstrate evaluative thinking by analyzing these exact trade-offs and justifying their decisions with evidence. If you spotted that relationship, you are perfectly executing step 2 of our blueprint. Extracting relevant data. Let's move immediately to challenge 2, find the flaw. Pause the explainer again and find the flaw in this sample paragraph regarding user accounts. It says, the school network requires all students to have a user account. The accounts are secured by passwords. Passwords are good because they stop people from logging in. The system administrator can see everything. Now, act as the Cambridge examiner. Identify the specific sentence that loses marks for lacking causal relationships and technical depth. Pause now. All right, did you catch it? If you pointed at passwords are good because they stop people from logging in, you are absolutely right. It is incredibly vague. It lacks any technical explanation of authentication or authorization. It doesn't explain how the password actually acts as a credential that's verified against a hashed value in the database.
And this perfectly transitions us to a massive, massive examiner alert. Look at this quote pulled directly from the principal examiner report. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Guys, this is the ultimate trap for students. If the question asks about a hospital's patient database and you just write a generic definition of a password without mentioning doctors or patients or medical data confidentiality at all, you will drop marks. You absolutely must contextualize. The theoretical architecture of the 9618 syllabus rests heavily on integration. You literally have to weave the theory into the specific fabric of the scenario you're given.
Okay, challenge 3, speed writing. It's time to execute the blueprint under pressure. Pause the explainer for 30 seconds to mentally draft, or jot down if you've got a pen handy, one perfect, context-specific, analytical PL paragraph. Explain why a banking app should use biometric authentication alongside passwords. Use our visual story memory hack. Imagine a vault with 2 distinct locks, something you know and something you are. Pause now. All right, let's break it down. Think about the point, 2-factor authentication. The evidence, requiring a password and a fingerprint. The explanation, mitigating the risk of compromised credentials. And finally, the link, protecting sensitive financial data in the banking app. If you structured your thought process exactly like that, you're thinking exactly like a top-tier candidate. You are evaluating alternatives and justifying recommendations, which are those crucial higher-order assessment objectives. Let's bring it all together into the final system. Here is how we troubleshoot those examiner pitfalls. Notice how clearly these common problems actually map to solutions. In a Formula One race, the telemetry data tells the engineers exactly where the car is losing time on the track. For us, the principal examiner reports act like our telemetry data. Mistake 1 from the reports. Answers on security measures are often way too vague. The fix? Inject specific technical details. Don't just write, protect the data. Write, implement role-based access control to restrict read/write permissions. Mistake 2. Students constantly forget to check boundary conditions in edge cases. And this is so crucial for algorithmic thinking. The fix? Rigorous edge case testing. Think about it. If you're writing an algorithm for password creation, what happens if the user inputs exactly 8 characters? What if they input 0 characters? What if they input a string of malicious SQL code? You must mention these boundary conditions. Evaluating the quality of an algorithm fundamentally requires identifying edge cases and their effect on system performance. This evaluative thinking is literally what secures the highest assessment objectives. So, let's consolidate everything we've learned into the ultimate system. Here are the 3 unbreakable rules that form the complete answering system. Rule 1. Command word decoding. Never ever start writing until you know exactly what the verb is asking you to do. Rule 2. Systematic framework application. Use the Peel method to structure your logic. Point, evidence, explanation, link. Make your algorithmic thinking visibly clear on the page. Rule 3. Contextualize every point. A brilliant technical answer is basically worthless if it doesn't solve the specific scenario in the question. Tie your security measures directly back to the user context provided. When practiced consistently, these 3 rules guarantee top marks in the user accounts and passwords topic. And I want you to notice the massive impact of these strategies. Students who implement these exact strategies see an average improvement of 2 full grade boundaries. 2! That is literally the difference between a C and an A. That is the true power of moving from chaotic memorization to systematic evaluative analysis. But here's the reality check. This only works if you practice consistently. You can't just watch this explainer once and expect to perform a flawless pit stop on exam day. It requires repetition, refinement, and dedicated practice of the methodology. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.
As we wrap up this masterclass, I want to leave you with one final provocative question. When you sit down in that exam hall, when the clock starts ticking, and you turn to that first challenging 9618 security question, will your next exam answer be a chaotic crash or a perfectly executed Formula One pit stop? The strategy is now completely in your hands. Implement the blueprint, respect those command words, and secure those method marks. Keep analyzing, keep evaluating, and I will see you in the next explainer.